In this video, the 13th in the Getting Started series, we will learn about inspecting your design and learn some additional functionality such as measure, interference, section analysis, center of mass, and mass properties. The Inspect menu in Fusion offers various tools for model inspection during the design process. These tools allow you to measure distances, check for interferences, section through assemblies to assess form, fit, and function, and calculate total weight. With the fishing reel assembly open, we want to take some measurements. Click on the measure icon above the Inspect menu, then click on the large cylindrical face of the spool. The measure dialog shows the radius and the diameter of the face that you selected. Click on the Clear Selection arrow to start a new measurement. Refer to Exhibit 1. If we wanted to find out the width of the main body of the reel, we can select the two side faces and it will show the distance of 16 millimeters between the two faces. Clear the selection and click on the fillet radius of the spool. The measure command returns the radius of the fillet. Another way to clear the selection is to just click out in the viewport. Now, click on the cylindrical surface of one of the holes in the spool, then click on the bottom edge of the spool. The measure dialog will show the radius and the diameter of the hole, along with the shortest distance between the hole and the edge of the spool. Refer to Exhibit 2. If we want to get the measurement from the center of the hole to the bottom edge, we will need to turn on the Show Snap Points option in the dialog. Clear the selection and hover over the cylindrical face of the hole and click. It will snap to the center point of the hole. Now, select the bottom edge and the result will show a distance of 3 millimeters. Refer to Exhibit 3. This method also allows for measuring curved surfaces. First, clear the current selection. Then, hover over the top curved edge of the tensioner and select its midpoint marker. Pan down to the bottom of the reel and select its bottom middle point. A direct measurement line will appear between these 2 points. Finally, click on the XYZ delta 1 icon to display the Z delta distance, which is a straight vertical measurement from the bottom point to the top plane of the top point. Refer to Exhibit 4. In Fusion, a handy trick for quick measurements is to simply click on a single entity. The measurement will then appear in the bottom right corner of your screen. For instance, clicking on a fillet will display its radius, and clicking on an edge will show its length. To measure distances between faces or edges, however, you'll need to utilize the dedicated Measure command. Another helpful tool for inspection is the Interference tool, which highlights overlapping or interfering parts. To use it, select Interference from the Inspect menu. Then, drag a crossing window from right to left over the handle and the handle grip. Finally, click the Compute icon in the dialog box. A table displays 2 groups with differing volume results. The larger volume highlights a screw with a greater diameter than the hole in the handle grip, requiring resolution. The other volume highlights a clashing filleted edge of the screw with the sharp edge of the handle's hole, also needing resolution for a tight fit against the handle's flat face. Click OK to close the table. Refer to Exhibit 5. Double-click on the screw in the viewport and notice it displays the name in the bottom of the screen. We can see that it's an M3 by 16 screw. Now, click the Edit and Place icon next to the handle grip component in the browser. A blue border will appear around the viewport, signifying that we are in the Edit and Place environment. Edit the hole feature in the timeline and change the size to 3 millimeters and the depth to 9 millimeters and press OK. Then click on Finish Edit in Place at the top of the viewport to accept the changes to the model. Refer to Exhibit 6. Turn off the fastener and then click the Edit and Place icon next to Handle Start. Add a 0.3 millimeter chamfer to the edge of the hole going through the handle. Press OK, and then Finish Edit in Place. You will get a warning that the screw has lost reference with the handle since we changed the edge it was originally associated with. Edit the fastener feature in the timeline and select the new edge to reassociate it. Press OK and notice that the warnings have been resolved. Refer to Exhibit 7. After rerunning the interference check, only one group now shows interference between the handle and the handle grip. We resolved the previous small interference by adding a chamfer to the handle. The remaining interference in the handle grip is expected and valid as the hole is drilled smaller for tapping, which is typical for a tapped hole size. The interference inspection successfully resolved the issues with the handle and the grip. The section analysis command, found in the Inspect menu, is another useful tool for identifying potential issues. After selecting the command, click on the front flat face of the reel to view a cross-section of the assembly. The blue arrow allows you to drag and slice through your design. Clicking on a cylindrical object will align the section plane with the center of that cylinder. You can also customize the section color or toggle the hatch visibility. Press OK to confirm the section view. Refer to Exhibit 8. Initiate another section analysis, selecting the top origin plane. Drag the blue arrow entirely above the assembly, then snap it to the center of the line roller cylinder. Upon zooming in, observe flashing and crisscrossed lines between the screw and the line roller, visually indicating interferences. This confirms the absence of a drilled hole in the line roller for the screw. Accept the section view by pressing OK. Toggle the screw's visibility off by selecting it and pressing the V shortcut key. This clearly shows the missing hole in the line roller. Press V again to restore the screw's visibility. Refer to Exhibit 9. An analysis folder now appears in the browser. Expanding it reveals our two section analyses. Activate Section 1 and observe the design from the front view on the view cube. From this perspective, the spool appears excessively close to the bail. Its diameter could be adjusted for a better fit. To modify the spool component, click Edit and Place in the browser. Then, expand its sketches and enable Sketch 1. The sketch's dimensions will become visible. If they are not displayed, right-click Sketch 1 in the browser and select Show Dimensions. Double-click the 38.5 diameter dimension and change it to 37.5. Observe how the model updates and how easily the result is seen in the section analysis view. Finally, click Finish Edit in Place and disable Sketch 1. Refer to Exhibit 10. To determine how well balanced a fishing reel feels during use, we need to find the center of mass of the entire assembly. From the Inspect menu, select Center of Mass. Then, in the browser, click on the top-level assembly and press OK. A Center of Mass icon will appear in the viewport. Viewing the assembly from the top view by clicking Top on the view cube, you might notice that the Center of Mass icon doesn't appear centered within the reel, which might seem unusual. This is because the center of mass calculation accounts for the mass properties of all of the individual parts, and some of our parts must have incorrect mass properties. Refer to Exhibit 11. In the browser, expand Handle Start. Right-click on Handle and select Properties. Observe that the material is currently listed as steel, which needs to be changed to ABS plastic. Close the Properties window. Next, edit and place the Handle Start component. Navigate to the Modify menu and choose Physical Material. Expand the Plastic folder and drag ABS plastic onto the handle. To refresh the display, turn off and then turn back on the Center of Mass display in the browser. You should now see that the center of mass has been updated and is more centralized. Refer to Exhibit 12. We can also find out how much the whole assembly weighs by right-clicking on the fishing reel assembly in the browser and selecting Properties. It returns a weight of around 265 grams. Let's save our design since we have made some changes. Click on the Save icon and notice that it is saving all of the components that we've made modifications to. In the next video, we will learn how to create a drawing set of our fishing reel design.